Look at this interface. A standard text response explaining orbital mechanics smoothly transitions into a functional, three-dimensional simulation of the Moon orbiting the Earth. Previously, asking an AI a complex question meant scrolling through paragraphs of static text and diagrams. Now we can generate real-time, customizable models directly in the chat. To build these simulations, start at the primary Gemini web interface on your computer. Before you start typing, check your account type. This simulation tool is strictly limited to personal accounts and is entirely disabled if you are logged in through a Google Workspace or education tier. Working with AI is shifting from reading generated answers to physically manipulating simulated environments to test how complex realities actually work. Open the Gemini web platform. Look past the main chat window and direct your attention down to the main prompt bar at the bottom. The default setting here is optimized for conversation. It does not load the computational rendering physics required to build functional simulations. You need to click the Model Picker drop-down menu and manually select the Pro option. If you skip this step and leave it on the default model, your prompts will only return standard text. Toggling to the Pro tier switches the system from a conversationalist to a computational physics engine. Even with the Pro model active, a standard question like, "How do orbits work?" will bypass the visualization engine entirely. This diagram outlines the required prompt structure, an exact trigger phrase followed by your complex concept. Use either "show me" or "help me visualize." For example, "Help me visualize how the Moon orbits the Earth." There is also a secondary failsafe. If you ask a highly technical question, watch for a button labeled "Show me the visualization" to appear under the text. Clicking that will also launch the render. The exact words you type directly dictate which operational mode the AI runs. Once the 3D canvas loads, the AI hands control over to you. You're the operator. You can physically manipulate the space. Click and drag across the canvas to rotate the model fully in 360 degrees. In the Variables panel, moving interactive sliders directly alters baseline physics, shrinking the central orbit as gravity strength increases. For precision, type exact data, like an initial velocity of 5,000, and the orbital path instantly snaps to that specific calculation. By forcing extreme values, you can visually distinguish exactly where a stable system collapses into an unstable one. Testing these limits, breaking and fixing variables yourself, builds a working comprehension that studying a static diagram cannot. Now that we have the mechanics down, let's look at how this visualization engine applies to other scientific disciplines. This rendering demonstrates an active black hole, visualizing exactly how its massive core creates gravitational lensing by bending the light of background stars. In molecular biology, you can prompt the engine to map the Krebs cycle, generating an animation that tracks the exact step-by-step electron flow and ATP production. For technical authoring, a prompt can explode the components of a 3E camera to detail how it actively renders a scene. Go to the Gemini web application, verify your account tier, set the model to Pro, and command the AI to visualize a concept you've always struggled with. This tool gives anyone with a personal account direct access to a functional laboratory housed entirely inside a standard chat window.